आइए देख लीजिए।
ओके स्टार्ट।
नहीं हुआ, थोड़ा आप आए हो ना इसलिए मैंने आराम से हो रहा है लाइव में है। बोर्ड ओपन है, इट्स गोइंग ऑन माय लैपटॉप वेरी स्लो,
बैटरी इज वर्किंग।
थैंक यू सर। नाउ आई एम गोइंग टू स्टार्ट द क्लास। Students, are you watching the board? Board is not responding, sir.
How many students attend joined?
Only 8. Wait for 1 minute. Actually, it is opening. Board is not responding properly. 8 students are watching. 20 students will give the attendance.
Attendance 20.
Maybe this, you see, numbers, roll numbers they give. Okay, students. Now today I'm going to continue the light chapter. Today we are going to discuss the applications of scattering. Yesterday I said what is scattering of light, right? Scattering of light means change in the direction of path of light due to the particles in the medium is called as scattering of light. For example, this is the some air particles or some dust particles, some smoke like this. For example, one light ray is coming along this direction, and now after passing through this, when it enters into this medium, right, due to these particles the direction of the path of light changes. That means actually it is trying to go in this direction in the straight like this, but due to the particles the path of the light ray is changed. That is the deviation or the change in the direction of path of light due to the particles in the medium is called as the scattering of light. Then we discussed yesterday which type of particles will scatter which type of light, right? Very fine particles means small particles can scatter the shorter wavelengths like blue color, right? And large particles, okay, with enough size, they can scatter the white light. Okay, yesterday we discussed a little bit. I am going to give today applications of scattering. Okay, I'm going to explain the applications of scattering. Now let us start. Why sky appears blue color? This is one application, and the second application is that during the sunset and sunrise, okay, sun and surrounding appears red color. What is the reason for that? That I am going to explain. Okay, right. You listen very carefully, and this is a very important topic. Okay, and everyone give the attendance. Right, today is the last topic. Okay, first one I am going to give, that is why sky appears blue color. Why sky appears blue color? Okay, for this answer I am going to give. In the daytime, when you will see the sky, it appears blue color. What is the reason? Why? This in one word answer is the scattering of light by the atmosphere. Okay. When one word answer is scattering of due to the scattering of light by the atmosphere. Okay. The reason is scattering of light. What happening? Scattering of light by the atmosphere. This is the reason. Why? How scattering occurs and why sky appears blue color? Let us discuss now. Okay. And for the purpose, it was very simple to understand this concept. I will explain clearly. Okay. Now you try to listen and understand the topic. Okay. Now I will start the topic, actual topic. That is why sky appears blue color. Let us start. And you see here, this is the earth. Okay. And this is the earth atmosphere. Right. This is atmosphere. Means it is the air. And now when sunlight starts and passes, okay, for example, the sunlight starts at here, this is the sun, and sunlight starts and passes. The sunlight is the white light, right? Sunlight is the white light. When it is enters into our earth atmosphere, what happens? There is a one scientist gave one formula. His name is Rayleigh. Okay, Rayleigh's scattering principle. What is that Rayleigh's principle? Rayleigh's principle is that scattering of light is scattering of light is inversely proportional to the fourth power of wavelength of light. Fourth power of wavelength of light. This is the wavelength. Wavelength power 4. This is the Rayleigh's principle. According to this, what is this? Scattering is inversely proportional to wavelength. If wavelength is less, wavelength denoted with lambda. Okay, this is the wavelength. Lambda. This symbol is the lambda. Okay, lambda. And now, if wavelength is less, then the scattering is more. Scattering is more, right? And if wavelength is more, the scattering is less. Scattering is less. You see here. Okay. And when this is a white light, right? The white light enters into from the sun, it will comes and it will enters into our atmosphere. After entering into the atmosphere, then due to the atmosphere particles, the light will be scatters. Light will scatter. Which color will be scatter more? Right? The blue color has the shorter wavelength, right? The blue color has shorter wavelength. Like this, light travel in all directions. But in this, the scattering of blue color is more after entering. Why scattering is of the blue color is more? Scattering means deviation. The blue color will be splits like this. Scattering of the blue color is more. The blue color will be splits after entering into the earth atmosphere. Okay, why? Because listen very carefully. Blue color has blue color has shorter wavelength, right? Why blue color have the shorter wavelength? When you will go for VIBGR, violet, indigo, blue, green, yellow, orange, red. When you will go to right side, the wavelength is increases. That means violet color, indigo color, blue color. they are having the less wavelength. Okay, and this red color, orange color has the more wavelength, right? The lambda of red color is much greater than the lambda of violet color, or the lambda of red color is much greater than the lambda of blue color. Okay, red color has the highest wavelength, violet color has the lowest wavelength, but our eye is more sense for the blue color than the violet and indigo. Then the blue color, violet color, indigo color, blue color have the shortest wavelengths comparing with the others. Why? Because when you will go from violet to red, the wavelength is increases. Means violet has less wavelength, indigo has some more wavelength, blue some more, green some more, yellow some more. Like this, wavelength will be increases when you will go to right side. Violet to indigo, indigo to blue, blue to green, green to yellow, yellow to orange, orange to red. Wavelength is increases. That means lowest wavelength is for the violet, indigo, blue, right? Lower wavelength are what? Violet, indigo, blue. In that our eye is more sense for the blue color only, right? Here the violet color will be deviates, indigo color will be deviates, blue color also deviates. Whenever the white light enters into, you see the figure, whenever cursor you should follow, whenever the white light enters into atmosphere, then that white light will be goes scatter. But when the white light has many colors, then in that the lower wavelength colors are the violet, indigo, blue. These scattering is more because according to the Rayleigh principle, Rayleigh is the scientist name, less wavelength has more scattering. Then the blue color, violet color, indigo color has a shorter wavelength and its scattering is more. Its scattering is more. When its scattering is more, okay, when its scattering is more, it will be deviate, and just like that scattered light, okay, scattered blue light, scattered blue light reaches our eye, reaches our eye, then sky appears blue color, then sky appears blue color. This is the reason why sky appears blue color. Okay, this is the reason why sky appears blue color, because very simple. From the sun, white light starts. That white light enters into our Earth atmosphere. After entering into our Earth atmosphere, the lower wavelength colors, violet, indigo, blue, scatters more. The blue color scattering is more because of less wavelength. When the scattering is more, then what happens? That scattered light will come to our eyes. That's why whatever that we will see, it will appear as blue color. Just like it is a scattering after entering. When it scatters, that blue color light will be distributed at the top of the atmosphere. Just like blue color paint type it appears. Right, in the daytime it will happens. Okay, but when the some note I will give. Have you understood this one? Huh? Give response. Everyone must be listen and maintain continually. You should be in the live. Okay, don't escape in the middle. Okay, if you have doubts you can ask me. Have you understood till now? Right, note, if the sky is observed, if we see the sky, then that is appears blue color because of scattering of light, right? But if astronaut, if astronaut in the spaceship, astronaut in spaceship, if astronaut in spaceship sees the sky, then it not appears blue color, it appears, it appears black because no scattering. Why no scatters? Astronaut is in the space. In the space there is no air. In space there is no atmosphere. Okay, astronaut will be in the space. In space, vacuum is there, no atmosphere. That's why no atmosphere means no scattering. Okay, scattering is occurred by the atmosphere particles, but there is no scattering. That's why. Okay, uh, sky appears blue color for the astronomer. astronaut. We can also assume one thing. For example, suddenly Earth atmosphere is disappeared. Then what is the color of the sky? Okay. You see in the night time. In the night time, white light also not there. That's why the sky appears blue color. Na? If atmosphere is not there, if atmosphere is not there, then also sky appears in the black. Okay. For the astronaut, sky appears in the black because no scattering. It will not appear in the blue color. Okay. Now, next. This is the reason. Next, one more application, and that is I'm going to erase this. If you want, you can take the screenshot. Next, one more application is that why sun and surrounding, why sun and surrounding appears red, appears red during sunset and sunrise, during sunset and sunrise. During sunset and sunrise, sun appears red color and surrounding also appears red color. What is the reason? Sun and surrounding, why sun and surrounding appears red color during sunset and sunrise? This is also one word, that is also due to the scattering of light. Okay, the one word answer is due to the scattering of light. Okay, answer is scattering of light by the atmosphere. Scattering of light by the atmosphere. Okay, right. Now I will explain why sun and surrounding appears red color during sunset or sunrise. Okay, you listen very carefully. This is very important. It may be come in the exam. Okay, and you have to hear very carefully. Let us see here. This is the earth. This is earth, and this is the atmosphere. Okay, atmosphere it is. Now here one person is there, and he is watching the sunset and sunrise. For example, this is the sunrise time. Okay, sunrise, and this is the situation during sunset and sunrise. What happens? Sun is at the horizontal, na? Sun is at the horizontal. This is also sun, but this is during sunset. Okay, this is the sunset time, and this is the sunrise time. Then what happens? In sunrise, in during sunrise or sunset, sun is at the horizontal. This is said to be horizontal. You see this. This line is said to be horizontal. Okay, horizontal. आदमी ऐसे दिखता है. But during afternoon, in the afternoon, sun is at exactly above his head. Right? This is the situation in the afternoon. Right? At 12 p.m. This is in afternoon. In afternoon, sun is above the head of the person, and in the morning is at here. In the afternoon it is at here. In the evening, right? It is at here. Like this, it will appear for us. Okay, sun. Now, what happens at here? This is a white light starts from the sun. White light will start from the sun. Okay, right? This is a white light, and this white light enters into atmosphere. When white light enters into atmosphere during sunrise or sunset, the light should travel long distance through the atmosphere. This much distance it can travel during sunset and sunrise. During sunset and sunrise, sun is at the sun is at the horizon. So light rays travel long distance through the atmosphere, through the atmosphere, long distance through the atmosphere. Okay. Why? You see, in the afternoon, this much distance it is traveling. This is the distance traveled in the afternoon through the atmosphere to reach the person. But in the morning and in the evening, this is the distance, long distance it is traveling. See here, in the evening and in the afternoon, it is traveling long distance through the atmosphere. Which is traveling long distance? Sunlight. Sunlight starts at here like this, travel long distance, right? Then while traveling long distance, what happens? One by one, colors will be scatters. Okay, first which color will be scattered? Okay, violet color will scatter, indigo color will scatter, blue color will scatter, right? Because they are having the lower wavelengths. Violet, indigo, blue colors will be scatters, right? And here the colors, lower wavelength colors. White has the many colors, na? White color has many colors. White light has many colors. With GR, 7 colors it has: violet, indigo, blue, green, yellow, orange, red. In that 7 colors, lower wavelength colors are what? Lower wavelength colors are what? Lower wavelength colors are the violet, indigo, blue, okay, and so on. Scattered more, right? They scattered more. They go to the side. Scattered more. They will go to the side like this. Scattered means deviation from its original path. Na? They will go to right side. But the red color has highest wavelength. Red color has highest wavelength. When red color has highest wavelength, right? When red color has highest wavelength, what happens? It has least scattering. Why? इसका वेवलेंथ ज्यादा होता तो उसका स्कैटरिंग कम होता है अकॉर्डिंग टू रेली प्रिंसिपल. ये वायलेट इंडिगो विबजीआर में वायलेट इंडिगो ब्लू ये वाला वेवलेंथ राइट साइड जाते तो इंक्रीज होता है. वायलेट इंडिगो ब्लू कलर को कम कम वेवलेंथ होता है, रेड को ज्यादा वेवलेंथ होता है. ये कम वेवलेंथ वाला को ज्यादा स्कैटरिंग होता है, इसलिए ये कम वेवलेंथ वाला पूरा बाहर चलेगा, साइड चलेगा, ऐसे साइड चलेगा. देन सब साइड चलेगा. कौन स्कैटरिंग नहीं होता है बताइए? देन रेड कलर हैज मैक्सिमम वेवलेंथ, इट्स स्कैटरिंग इज लेस because the scattering is inversely proportional to wavelength, right? We know that one. Scattering is inversely proportional to fourth power of the wavelength. If wavelength is less, scattering is more, right? Now according to that, red color has the highest wavelength, it has the least scattering. मतलब ये वाला साइड नहीं जाता है, सब कलर्स साइड जाएगा, एक कलर बचेगा. देन दैट इज रेड कलर. ये रेड कलर आपको किसको कहाँ पहुंचेगा? रेड कलर आपका आंखों में पहुंचेगा. इस कौन कलर पहुंचेगा? रेड कलर पहुंचेगा. बाकी कलर्स क्या होगा? स्कैटर होगा, राइट? आंख को क्या कलर रीच हो गया? रेड कलर रीच हो गया. वायलेट साइड चला गया, ब्लू साइड चला गया, इंडिगो साइड चला गया. Okay, सब color side चला गया because they have the less wavelength comparing with the red color, and then only red color has maximum wavelength and it has the least scattering. That's why ये वाला side नहीं जाएगा, उसको deviate नहीं होगा, deviate नहीं होता है. then सीधा जाएगा red color, bend नहीं होता है, इसलिए red color आंखों को reach होता है. then red color reaches the person's eye. रेड कलर रीचेस द पर्सन साइड, बाकी सब कलर्स स्कैटर होता है. रेड कलर पर्सन हाई को रीच होता तो reaches person's eye, whatever that he will see, कोई भी देखते तो ये वाला रेड कलर में दिखाता है. Red color reaches the person's eye, that's why everything appears in the red color. That's why everything appears in red color, right? Okay, this is the thing. And the next one is, what about in afternoon? आफ्टरनून में किस कलर में दिखाएगा? देखिए, आफ्टरनून में देखा होगा, कई एनीवन कैन गिव कलर, व्हाट इज द कलर ऑफ द sun in the afternoon? Write in the chat box, what is the color in the afternoon? In the evening, in the sunset, during sunset and sunrise, sun appears red color, surrounding appears red color. Why red color? Because of scattering. All the colors, violet, indigo, blue, red colors will be scattered. Sorry, violet, indigo, blue colors will be scattered because of less wavelength, but red color has maximum wavelength, it has least scattering, it does not have the scatter, and it can go straight. That's why person's eye, red color will reaches the person's eye, that's why red, whatever that he will see, it appears red color. In the afternoon, then all the colors will not scatter. Some blue color will scatter, violet color will scatter, but all the colors not scattered. That's why sometimes it appears as one time it appears as for example, इसमें सब कलर्स का स्कैटरिंग नहीं होगा, बिकॉज आफ्टरनून में ज़्यादा डिस्टेंस ट्रैवल नहीं कर रहा है ना व्हाइट लाइट. व्हाइट लाइट आ रहा है सन से, बट आफ्टरनून में एटमॉस्फेयर से ज़्यादा डिस्टेंस ट्रैवल नहीं कर रहा है. इसका वजह से सब कलर्स डिवेट नहीं होगा, बेंड नहीं होगा, राइट. एंड देन एक बार ब्लू कलर रीच होगा, एक बार ग्रीन कलर रीच होगा, इसलिए अलग अलग कलर, ग्रीन कलर, ब्लू कलर, व्हाइट कलर ऐसे चेंज होता जाता है. किस कलर आप आंखों में रीच होगा, कलर में दिखाएगा, बट शाम में खाली रेड कलर रीच होगा, बाकी कलर स्कैटर होगा. क्यों? शाम में लाइट आंखों को रीच होने के लिए एटमॉस्फेयर से बहुत दूर जाना होता है, इसका वजह से सब कलर स्कैटर करके खाली रेड कलर स्कैटर नहीं होता है, रेड कलर आंखों को रीच होता है, राइट. हैव यू अंडरस्टूड स्टूडेंट्स? एनी डाउट? And one more point I am going to explain why danger signals which indicated with the red color, हम लोग डेंजर सिग्नल्स रेड कलर से इंडिकेट करता है क्या? क्यों, क्या रीजन हो सकता है? हाँ, रेडियम से रेड कलर दिखाता है, डेंजर लाइट रेड कलर में होता है. डेंजर लाइट रेड कलर में क्यों होता है? हम लोग को बाइक के पीछे में लाइट लगाता है एक रेड कलर वाला, राइट, रेड कलर वाला फ्रेम होता है, उसका रीजन क्या होता है? रेड कलर क्यों लगाना होगा? राइट, रेड कलर light can travel long distance without scattering, right? Why? Traffic signals are something indicated with the red color, because the red color can travel the long distance, that's why. Okay, and one last topic is the experimental study of the scattering. One experiment we will discuss to study the experimental experimental study of scattering. One experiment that shows the scattering practically we can do, right? How we can do that experiment, I will explain, you listen very carefully. Okay, and this is a source of the white light. S is the source of white light. S is the source of white light. Okay, and here from this white light will starts. Here we are using one convex lens, and the latter after the convex lens we have to use one container. After this container we can keep one paper with a circular hole. After this we will keep one screen, one convex lens. After the convex lens we will keep the screen. This is the arrangement, this is the screen. Screen means white paper. This is a hole. Okay, this is the hole, circular hole, and it is the convex lens. Convex lens, other name is what? Can anyone type? What is the other name of convex lens? What is the other name of convex lens? It's a container. It is the source of white light. Now here white light started at here. For example, this is the white light. White light starts at here and incident on the lens. The source is placed at the focus. Then when the source is at the focus, then light rays will travel in a straight line like this. They will become the parallel beam. When the source is placed at the focus of the lens, then the light rays become parallel. And now here in this container, we have to take the 2 liter water, 2 liter water plus 200 gram sodium thiosulfate, sodium thiosulfate, sodium thiosulfate means I think Na2SO3, and along with that 1 or 2 ml sulfuric acid also we can add. 1 or 2 ml sulfuric acid. Okay, sulfuric acid we have to add. First we have to make the 2 liter water with 200 gram sodium thiosulfate. This we have to make a solution, and after making a solution, right, then you have to add the 1 ml sulfuric acid. This sulfuric acid will act like a uh, in that sulfur particles will act as a colloidal particles. They will be sulfur particles will be there in this solution. ऐसे वाटर में सल्फर पार्टिकल्स होता है. ये सल्फर पार्टिकल्स क्या करता है? ये लाइट को डिविएट करता है, स्कैटर करता है, राइट. स्कैटर करते तो कैसे चलेगा लाइट? देखिए, ऐसे लाइट जाएगा, then इधर से आएगा वापस ऐसे, एंड नेक्स्ट इधर नैरो बीम लेंस का ऊपर में इंसिडेंट हो जाएगा. ये वाला फिर से पैरेलल बीम को कन्वर्ज करेगा, स्क्रीन का ऊपर में आप लोग देखेगा. नाउ आपका कौन सा कलर स्क्रीन का ऊपर में दिखेगा, राइट? लेट अस डिस्कस नाउ. ऑन स्क्रीन क्या दिखाता है? ओके, ऑन स्क्रीन फर्स्ट ऑरेंज, नेक्स्ट रेड कलर अपीयर्स. ओके, फर्स्ट ऑरेंज रेड कलर्स एंड देन क्रिम्सन रेड कलर ऑब्जर्व्ड. ओके, ऑन स्क्रीन फर्स्ट क्या ऑब्जर्व होता है? ऑन स्क्रीन फर्स्ट ऑरेंज कलर, first orange comma sorry first orange red color appears, first orange red color, and then crimson red color, dark red color appears. Okay, and one more point is observed that on three sides of the container, for example this side blue color appears, this side completely blue color appears, this side blue color, and this side also blue color appears, and this side also blue color appears, but this side it appears as red color. What is this? What happening it here? I will explain clearly. Okay. Now what happening it here? Three sides. Okay. For the other three sides of the tank. Okay. This is a tank. We can take it as tank also. Okay. Tank has four sides, na? Out of four sides, three sides appears as blue color and one side appears as red color. Okay. What is this? Why it is happening? Three sides of the tank, three sides of tank appears blue color. Okay, and the side which is towards the screen appears red color. This is observation in the screen. I will explain the reason. These are observations. What we are doing, I will repeat the experiment. Okay, very carefully you have to hear. And this is the source of white light. This is placed at the focus of the convex lens. Then when the light is source is at the focus, then the light rays will become the parallel to the principal axis. They will go like this. And here we are placing a tank. You see the cursor figure. Okay, I will repeat again. This is the source of white light. This white light is placed at the focus of the convex lens. Then the white light starts, and then this will become parallel after passing through the convex lens. And here we are placing the one tank. In that tank, we are filling 2 liter water, 200 grams sodium thiosulfate. We have to make a solution, and in that, lastly, we add the 1 or 2 ml sulfuric acid. We have to add. In that, what happens? It will appear just like white color, white water only. It will appear just like water only. And next, after that, what happens? In that, sulfur particles are there. Here, sulfuric acid we are adding. That's why sulfur particles will be there. These sulfur particles will act as a colloidal particles. Colloidal particles means suspended particles. They will be present in the solution. When the white light enters into the solution, that white light will be scattered. Is it right? White light will be scattered. Then it has the 7 colors. Then in that, out of 7 colors, which colors will be scattered more? Tell me, right? Violet, indigo, blue have the less wavelength. Is that right? Less wavelength. That's why their scattering is more. Their scattering is more, right? But our eye is more sense for the blue color only. Then the blue color will be scattered more, violet color scatter more, indigo color scatter more because of less wavelength. They will go to the side, and due to the sides, then the four sides, this side, this side, this side, blue color passes. That's why the three sides will appear as blue color. And one more is red color. What about the red color? Red color has the highest wavelength. Red color has the highest wavelength. Highest wavelength means its scattering is less. Scattering is less means it will not deviate. Okay, scattering means going to side, but scattering is less means it will not go in the straight. It will go in the straight, that will not go to the side. Scattering less means सीधा जाता है. Scattering नहीं होते तो. Scattering होते तो डायरेक्शन चेंज करके जाता है. ये वाला स्कैटरिंग है, ये वाला स्कैटरिंग नहीं है. रेड कलर स्कैटर नहीं होता है, इसका वजह से रेड कलर सीधा जाएगा. मतलब व्हाइट लाइट आ गया, ये सॉल्यूशन से पास हो रहा है, ये सल्फर पार्टिकल्स, कोलाइड पार्टिकल्स क्या करेगा इसमें, व्हाइट लाइट को स्कैटर करेगा. व्हाइट लाइट में वायलेट, इंडिगो, ब्लू लेस वेवलेंथ होता है, उसका स्कैटरिंग ज्यादा होता है. ये सब वायलेट, इंडिगो, ब्लू कलर साइड जाएगा, बट रेड कलर साइड नहीं जाएगा. रेड कलर क्यों साइड नहीं जाएगा? रेड कलर हैज द हाईएस्ट वेवलेंथ, राइट? इट्स स्कैटरिंग इज लेस, दैट्स व्हाई रेड कलर सीधा जाएगा. रेड कलर बाहर आएगा. किस फेस से रेड कलर आ रहा है? इस फेस से रेड कलर आ रहा है. इसका वजह से ये फेस आपको रेड कलर दिखाएगा, बिकॉज इस फेस से कौन बाहर आ रहा है? रेड कलर लाइट बाहर आ रहा है, इसका वजह से ये फेस रेड कलर दिखाता है. बाकी फेसेस ब्लू कलर क्यों दिखाया? ब्लू कलर स्कैटर हो गया. स्कैटर हो तो बेंड हो जाएगा, बेंड होता तो सब डायरेक्शन में स्प्लिट हो जाएगा. ऐसे ब्लू कलर इधर साइड गया, इधर साइड गया, इधर साइड गया, इसको तीनों साइड ब्लू कलर डिस्ट्रीब्यूट हो गया, पीछे भी आ गया. बट एक साइड खाली रेड कलर गया हुआ, इसका वजह से इस साइड रेड कलर दिखाएगा, बाकी तीन साइड ब्लू कलर दिखाएगा. एंड ये रेड कलर लाइट बाहर आया, ये वाला होल से गया होता है, जाता है, ये वाला लेंस का ऊपर में इंसिडेंट होता है, बाद में ये वाला कन्वर्ज होगा स्क्रीन का ऊपर में. देन दिस इज आल्सो अपीयर्स इन द रेड कलर, right? Okay, this is the experimental study of scattering, and the same appears in the this only happens, why sky appears blue color and why सन अपेयर्स रेड कलर ड्यूरिंग सनसेट एंड सनराइज। देखिए इसमें तीनों साइड ब्लू कलर में सेम है। हमारा व्हाइट लाइट अर्थ एटमॉस्फेयर में एंटर हो रहा है, उस समय में कौन कलर ज्यादा एंटर स्कैटर होता है? ब्लू कलर। इसका वजह से आफ्टरनून में ब्लू कलर दिखाएगा, शाम में क्या होता है? रेड कलर दिखाएगा। इस साइड दिखाता है, शाम में हम लोग हॉरिजॉन्टल में देखता है, हॉरिजॉन्टल में देखते तो आपको रेड कलर दिखाता है, राइट। आप स्क्रीन साइड रख के देखते तो रेड कलर दिखाएगा, आप वो दूसरा साइड कंटेनर का दूसरा साइड जाके देखते तो ब्लू कलर दिखाएगा। दिस इज द एक्सपेरिमेंट। ओके, हैव यू अंडरस्टूड? इज इट क्लियर स्टूडेंट्स? विद दिस our 10th class syllabus is completed, and the next I will start the lectures for the revision. CBSE most repeated questions and answers I will prepare, and that question answers I will explain in the live in the revision part. Okay, and in our syllabus we have the 5 chapters. Out of 5 chapters, one chapter is totally deleted, sources of energy, and then we completed the 4 chapters. What are the 4 chapters we completed? First one is the electricity, we completed. Second one, what we completed? Tell me. Second one, what we completed? Light reflection and refraction we completed. Third one, what we completed? Human eye and colorful world and magnetic effect of electric current. These 4 chapters we completed. Once again, I will repeat: electricity completed, magnetic effect of electric current completed, okay, and light reflection refraction completed, human eye and colorful world just now completed. Now अभी हम लोग डिस्कस किया ह्यूमन आई एंड कलरफुल वर्ल्ड। इसका पहले क्या डिस्कस किया? उसका पहले क्या डिस्कस किया? मैग्नेटिक इफेक्ट ऑफ इलेक्ट्रिक करंट। उसका पहले लाइट रिफ्लेक्शन रिफ्रैक्शन। उसका पहले इलेक्ट्रिसिटी। ये 4 चैप्टर्स हम लोग कंप्लीट किया। इससे हमारा सिलेबस फिजिक्स का खत्म हो गया। नेक्स्ट क्लास कंटिन्यूअस क्लासेस मिस मत हो जाओ। देन उस कंटिन्यूअस क्लासेस में मैंने बताएंगे आपको मोस्ट रिपीटेड सीबीएसई क्वेश्चन आंसर्स। ओके, एग्जाम में 90% आने वाला क्वेश्चंस को हम लोग डिस्कस करेंगे। ओके, लाइव में ऐसे एक्सप्लेन करेंगे आपको क्वेश्चन और आंसर्स। ओके, this is the thing. And is it clear students? Today topic is most important. Today and yesterday topic you will get the exam, you will get in exam. Okay, thank you, and I am going to close the live. And if you not give the attendance, you give, and then we will close. Students, you are giving the attendance and leaving the class. Only 9 members are watching now, right? All the others are went. Then it is not at all good. uh, don't do like this. This will be problem for you. Students, you are